I'm going to continue this lecture where I last left off in the last video. I have the locale project open. I had just left off printing out the date in 6 different locales, all of them English speaking. In the next example, I want to use non-English locales. To demonstrate this, I'll create a new datetime formatter instance using the ofPattern method. I'll call this variable wDayMonth. I'll assign that the value I get back from the static ofPattern method on this class. I'm going to pause here a minute and hover over datetime formatter. Nothing is happening when I do that. The reason is I have not enabled the hover option in the IntelliJ settings. I can view the documentation by selecting datetime formatter and pressing Ctrl Q. But I like the hover feature, so let's enable it. Go into Settings in IntelliJ and select Editor and Code Editing. Then click the checkbox to the left of Show Documentation on hover. Save and close settings. And now if I just hover over datetime formatter, the documentation will show. Pretty neat. I'll now just scroll down on this pop-up until I see the section on patterns for formatting and parsing. Here I can see what I need to put in my date pattern. In my case, I want to print the full day of the week, Monday or Tuesday for example, a comma, the full name of the month. I'll follow that with the numeric day of the month and the full 4 digits of the year. If I examine this, I'll see that the day of the week is capital E, and month of the year is capital M, lowercase d will be the numeric day of the month, and I can use either lowercase u or y for the year. If I scroll down a little further, I can see more instructions. What I'm interested in is how to use these codes to get the full weekday and the full month. Here I see that exactly 4 pattern letters will use the full form, and that's what I want. This means I'll set up my pattern with 4 capital E characters to get the weekday text fully printed out, and 4 capital M's to get the full month printed. After that, I want a single lowercase d for the numeric day of month, a comma and 4 lowercase y's. Next I'll again set up a local date for May 5th, and in this case I'll just use the year 2020 so we can all get the same output. I'll print a separator line and then set up a for loop, much like I did previously. This time though I'll use a different set of locales. I'll use many of the constants on locale, so Canada, French. I'll use countries for the rest of my examples, so France, Germany, Taiwan, Japan, and Italy. In this loop, I'll print out the display name as I did previously, but I'm going to do this twice. First, I'll call the no-args version, and after that, the overloaded version that takes a locale. After I print the second displayed name, I'll include a new line and a tab, and I'll print May 5 formatted with the wDayMonth format using the current loop instance's locale. If I run this code, what I want you to see is that Java supports localization for the display methods on locale. I can see this data printed in my own locale, which I see first, and in the locale that is represented by the loop locale. This is the same for the first one because we've set the default locale to ENUS, so both are printed in English. After that, the display names are first in English and then in the language of the locale. You can also see the full day of the week and the full month printed in the date in the correct language for that locale. For good measure, let me show you that I could print this same date out using printf, an overloaded version that takes a locale as its first argument. The specifier is always %t. I only want to pass the date as the first argument, so I'm using the argument index $1 in each specifier. Capital A gives me the full weekday, capital B gives me the full month text. If I use lowercase e rather than lowercase d, I'll get a single digit for day rather than always 2 digits. And I can use capital Y to get a 4-digit year. Running this code. You can see this gives me the exact same output for all locales. The method string.format also has an overloaded version that takes locale. I will just change printf to print and include a call to string.format in the call. IntelliJ is telling me this is redundant, but I wanted you to see that string.format supports locale as well. If I run that, I get the same result. Now I want to look at currency and numbers. Java provides a number format class that will take a locale to help us properly format numbers and currencies. Let's see what a decimal number looks like in multiple languages. First, I'll create a number format variable, decimal info, and assign that the result of calling the static method getNumberInstance on that class, passing it my loop's current locale instance. I can use this variable and the format method to print a double literal. Running this code, you'll see this number printed for each locale. A decimal point in some languages is a period, and in others it's a comma. Notice also that numbers have different grouping separators, separating groups of thousands and millions and so on. In English, these are commas, but in French these are spaces, and in German they are periods. By default, a number format instance uses only 3 fractional places. Number format lets us change that, so I'll add a statement. After I create this numeric format instance, I'll call set maximum fraction digits and set that to 6. This means number format is a mutable class. If I run this, you'll see that I get all 6 digits printed after the decimal in each case. I will do something similar with currency. In this case, I'll use the static method, getCurrencyInstance with the locale. I'll print the currency amount of 555.555. Running this, I'll now see each country's method of displaying currency with a currency symbol and using the number formatting as well. I purposely used an amount with 3 decimal places, but you can see in almost all cases the least significant digit was dropped. For Japan, the amount was rounded up to a non-fractional amount. In addition to this method on number format, Java has a currency class that can give us more information about a locale's currency. First, I'll insert a statement directly above the last line of code in the for loop to create a local variable type currency called local currency and call currency.getInstance with the locale variable. Next, I want to print some information about the currency in my last println statement. I'll start by adding an opening square bracket and including a new line. I'll print the locale's currency code. I'll print the textual name for the currency in that locale's language. I'll use my locale's language for the currency display name. If I run this code, you can see I get the currency code and the explanation of the currency code in the loop locale's language first, followed by English. Next, let's consider keyboard input for a moment and talk about the scanner class and locales. First, I want to create a big decimal variable. Using a string to construct it, I'll call this variable myloan and pass $1,000.50. I'll include a 1,000 separator in English, so a comma in this case. I'll print that out. Running this code, I actually get an error. Remember that this string, when passed to a big decimal constructor, can't have any characters other than a decimal symbol and digits. But the scanner class will take this grouping symbol as input. I'll add 2 statements before the variable declaration for my loan. I'll create a new instance of scanner. I'll prompt the user to enter the loan amount. Next, I'll use a method on scanner that lets me read in a string and create a big decimal value out of it called nextBigDecimal. I'll replace that big decimal constructor and call this method instead. I am going to run this, and at the prompt, I'll enter the same string value I used when I tried to construct a new big decimal. So 1,000.50. Now in this case, the method nextBigDecimal will use the locale to test if this is a valid number. This method accepts a locale's group separator and decimal separator characters. I can change the locale used by the scanner by calling the useLocale method on scanner. I'll insert this before I execute the code to get input, and I'm going to pass the Italy locale because it has period as the group separator and a comma as the decimal operator, which is the opposite of US English. If I run this and enter the same data I did previously, I'll get an exception. The scanner knows this input isn't appropriate for a big decimal number for the Italy locale. I'll run this again, and now switch the characters used, so I'll enter 1.000,50. This code runs and reads the big decimal value, printing it out in the US EN locale. I can set up a number format using the Italy locale to print it out for that locale. And I'll change the system.out.println statement to use that. Now if I rerun that, entering the same data, my user input will be the same as the output. Okay, so I hope you can see that Java provides quite a bit of support for locales. You've seen that it has language support for weekday, month, country code, language and currency textual data, and provides formatting for dates, currencies and numbers. For additional language support, if you plan to provide an internationalized application, you'll need to provide translations yourself and store these translations in special resource files called resource bundles. Before I cover that topic, I first want to give you a challenge to review some of what you've learned about dates and localization. Let's do that in the next video.